Welcome to section 1.4 of Pre-Calculus 20. So here's a little warm-up for you. I just want you to take a look at these four sequences here, and I want you to determine if they are A, arithmetic, or if they are, I guess, G, geometric. So I want you to hit pause and try to figure that out, and when you come back, I'll have the answers ready for you and we'll discuss them very briefly. So go ahead and hit pause now. Alright, welcome back. So let's take a look at these answers, see how we did. The first one is an arithmetic sequence, and it has a common difference of minus 6. So to get from 23 to 17, we jump down by 6. To get from 17 to 11, we jump down by 6. So that's how we figured out that that was arithmetic. This one was a little trickier because they're all different fractions, and this one's not even a fraction, it's a whole number. But if we all write them all with a common denominator, 5 over 2 is the same as 10 over 4. Then the next one is 11 over 4. Now 3 can be written as 12 over 4. And then 13 over 4. So you see that basically what we're doing every time is we're adding one more quarter. So here our common difference is 1/4, and that's arithmetic. This one is a geometric sequence. So we start off with 2. If you thought it was arithmetic, you would say, oh, we add 4, but then the next one, we don't add 4. Okay, that's a huge jump. So as soon as you see that it's not 4 and then 4, you know it's not arithmetic anymore. So this one, we multiplied by 3. If you take 6 and multiply it by 3, you get 18. So we find that this is geometric, and the common ratio R is 3. Here again, we start out with 1. We go down to 1/2. Okay, so if we subtracted a half, we would be there, and then if we subtracted a half again, we'd be at 0. And this one's not 0, so again, that tips us off that it's geometric. So we go 1, 1/2. If we multiply that by 1 over 2 again, doubles the denominator. Multiply it by 1 over 2 again, doubles the denominator again. So this is our common ratio. R is 1/2. All right. Another warm-up, find the 15th term of the geometric sequence. Okay, so I've put the formula up here for you to look at. I want you to hit pause again, give this one a try, and we'll go through the answer quickly when you come back. So go ahead and hit pause now. Alright, welcome back. So let's quickly look through this. So we want to find the 15th term, so that's Tn. So all of our given information right here, T1 is 4 from right here. R is our common ratio. What do we have to multiply these by to get to the next term? You see that it flip-flops from negative to positive, so our ratio must be negative. 4 times what is 12? The answer is 3. And then what else is given to us? The 15th term, so that's n. N equals 15, and we want to find Tn. That's our question mark. So here we go. T sub n equals 4 times negative 3 to the power of n minus 1. It's 15 minus 1. So T sub n equals 4 times negative 3 to the power of 14. Now, here's where you need a calculator with a special button on it. A button that says x to the power of y. So then you'd type in negative 3, and then you'd hit this button, x to the power of y, and then you would type in 14 after that and hit enter. And Google will spit it out for us. 4,782,969. 4,782,969. So 4,782,969. And it will be a positive number because this is an even number. Okay, so then we have to multiply that by 4. So let's take another look. Hit times 4. There's our answer. 19,131,876. So 19,131,876. There you go. 19,131,876. 6. All right, on to the next part. For the geometric sequence defined by this, so it goes 3, then it goes 1, then it goes 1/3. So every time to get to the next term, we divide the previous one by 3. Therefore, our R value is 1/3. Now, here's our formula, and if we want to try to figure out which term is equal to 1 over 243, here's where we're looking for n. Now, this is going to be a tricky one. There's a couple ways to do it. I'll show you the long way, but the easy way first, and then I'll show you the shortcut right after that. So 1 over 243 equals this is all our given information. Now here's a problem because our variable is in the exponent, so we can't evaluate this and then solve easily. So here's what I would do. I would write down the terms. So term 1 is 3, term 2 is 1, the next one is 1/3. So we divide by 3 again, we get 1/9. We divide by 3 again, we get 1 over 27. Divide by 3 again, we get 1 over 81. And if we divide by 3 again, we get 1 over 243. So it ends up being the 7th term. So right away we can say that T7 equals 1 over 243. And we'd be right. There is another way to do it. It involves a little bit of trickery, but I'll show you how. So we have this equation set up. Now to try to start isolating this thing, we could divide both sides by 3. So 1 over 243 divided by 3 is the same as 1 over 243 times 1/3. And that's equal to 1/3 to the n minus 1 on the other side. All right. Now, 243. This is an interesting one. 243 we can rewrite as 3 to the power of what? Well, let's see. 3 times 3 equals 9 times 3, 27, so that's third power, that's fourth power, that's fifth power right there. So 3 to the power of 5, and then times 1/3 equals 1/3 to the n minus 1. Now, this is 1 over 3 to the power of 5, but we're multiplying it by 1/3 again. So really on the left side we have 1 over 3 to the power of 6 equals 1 over 3 to the power of n minus 1. Now in order for these two sides to be equal, 6 has to be exactly equal to n minus 1 because they have the same base. So 1/3 to the 6 has to be equal to 1/3 to the n minus 1, and therefore 6 equals n minus 1. And then if you go ahead and solve for n, you add 1 to both sides, and you get n equals 7. And that was what we had figured out in the first place, which was our answer there. So today we're going to start looking at geometric series. It's just like an arithmetic series where we add the sum of all the terms in the sequence, except now that it's geometric, we're using a common ratio instead of a common difference. So here's where your notes start. So a geometric series is the expression for the sum of all the terms in a geometric sequence. So rewrite this sequence here as a geometric series. So again, it's a sum of all the terms in a sequence. So go ahead and hit pause. When you come back, the answer will be there for you. So hit pause now. Okay, so there's what that looks like as a geometric series now. All you've done is taken and put the plus sign in between each one of those terms. Find the sum of these. So it's a matter of punching them into your calculator. So you can go ahead and do it, or whatever. Here's the answer. Okay, 2186. Look for a shortcut to the sum. If you want to try to do this, I'll leave it up to you to try to work something out on your own, but it might be a little difficult. All right, so here's how we develop a general formula for the sum. So let's write out a general geometric series. So we start out with Sn. This is the sum of n terms that we want to look for, all right? So we take our first term, t1, and we add it to our second term. And our second term is always the first term times the common ratio. So the second term is t1r. Okay? Now the third term would be t1 times the common ratio twice. So the third term is t1r squared. And it would continue like this all the way up to however many terms you have in the series. So the fourth term is t1r cubed, and then it would continue that way until we get t1r to the n minus 1. Alright, so this would be the last term in the series. Okay, so now we're going to take that same series, that same sum of all those terms, we're going to multiply the whole thing by the common ratio r. So we multiply the left side, then we multiply every term on the right side. So the left side, instead of Sn, becomes r times Sn. Okay? Now that will be equal to the common ratio multiplied by each one of these terms. So t1 becomes t1r. t1r becomes t1r squared. t1r squared becomes t1r cubed. Okay, and the trend continues all the way down to our final term, where t1r n minus 1 becomes t1r n, because we're multiplying it by r. Alright, so now we're going to subtract the two equations. So we'll start with this one that we've multiplied by the common ratio. So Rsn is equal to t1r plus t1r squared plus t1r cubed plus t1r to the n minus 1 plus t1r to the n. So we go all the way to the end of this one. Now we're going to subtract the original one, which was just the sum s sub n. And we're going to s sub n looks like that. Okay. When we subtract these things, you notice that there's a whole bunch of common terms that are going to cancel off. So let's start with over here, Rsn minus Sn on the left side. Okay, so it looks like that. Now on the right side, we have nothing minus t1, and that would give us a negative t1. Now we have t1r minus t1r, 0. t1r squared minus t1r squared, 0. t1r cubed minus t1r cubed, 0. t1r to the n minus 1 minus t1r to the n minus 1, 0 again, and then finally we do have a term left over here because it's t1r to the n minus 0. So all we're left with now is minus t1 and t1r to the n. So we're going to have to isolate tn. So let's start with the left side. Isolate s sub n, sorry. So we take out a common s sub n from these. So it's s sub n times r minus 1 on the left side. On the right side, it's negative t1 plus t1r to the n. Okay? So let's continue to get Sn by itself. We divide by r minus 1. Those cancel over here. Divide by r minus 1 over here. Now we have an expression for the general sum of the series s sub n. And here you can just take out a common t1, multiply it by negative 1 plus r to the n over r1. And this is our general expression. So here it is. Here's a sum of all the ideas that we just went through. T1 is the first term. R is the common ratio. You can write all these down in your notebook. Here's the form of the equation that we will be using, the formula. So go ahead and copy that down, hit pause, and then come back and we'll move on. So here we're going to do an example. Determine the sum of the first 10 terms of each of these geometric series. So I've written down the given information for the first one. So T1 is 4. To get to 12 and then to 36, you multiply successively by 3. And we are looking for the first 10 terms, so n equals 10. So we want S sub n. So we plug in our given information here. So T1 is 4. R is 3. And we are doing that to the power of n, which is 10. Then we're going to subtract 1. Then we're going to divide by r minus 1. And r is 3. So 3 minus 1. So S sub n is 4 multiplied by something divided by 2. Now in here, 3 to the power of 10. Go back to trusty Google, and 3 to the power of 10 equals 59049. So 59049. Now, the 4 and the 2, this will cancel to give us 2 over 1 instead. So the sum of the first 10 terms is going to be 2 times 59,049. Let's go back to Google, multiply that thing by 2, 118,098. So 118,098. And that's the sum of the first 10 terms. Would be kind of annoying to do this whole thing, just adding every term after term after term in your calculator, and it would be fairly time consuming as well. So let's look at the second one here, B. So T1 equals 5, R equals 1/2. All we're given are the first term in the common ratio, but that's nice, we don't have to find anything. So n will still be 10, and we want to find the sum of the first 10 terms here. So again, we go back and look at our formula, and that's what it looked like. So T1, 5 times R, which is 1/2, to the power of n, which is 10. Subtract 1 inside the brackets, then divide by 1/2 minus 1. Okay? S sub n, so 1/2 to the 10th. I'm not going to do it in Google here, actually. We can figure this one out just on our own and leave it in fractional form. So 2 to the power of 10 is what the denominator will be. So 2, 4, 8, 16, 32, 64, 128, 256, 512, and then 1024. So it will be 5 times 1 over 1024, and we're subtracting 1 from that. And then we are dividing by 1/2 minus 1, which is negative 1/2. So this one gets kind of ugly. 1 over 1024 would be 1 over 1024 minus 1024 over 1024. And this is all going to be over negative 1/2. So 1 minus 1024 is negative 1023 over 1024. Ugly one. We're going to multiply that by 5 and then divide it by negative 1/2, which is the same as multiplying by negative 2. So we're going to multiply this whole thing by 5 and negative 2. So negative 10 times this whole thing, and 1024, and we find that we get a positive value, and we get positive that over 1024. So this is a 3 0. Okay, that's our answer. So here's your turn for you to go ahead and try. As always, hit pause. The answer will be here when you come back. So there's the answer. Hopefully you were able to get that. So we're going to stop here for the day. So good luck, and I will see you in class tomorrow.